ओके सो आजको भिडियोको टाइटल हामीले देखिसकेका छौँ ड्रब्याक्स अफ रुदरफोर्ड एटोमिक मोडल भनेर. Yes, we have already seen the title. So we have already read about Rutherford's atomic model, right? Rutherford atomic model, it was initiative for developing other atomic models. It was an encouragement, yeah, actually. So actually we know now that it is not the correct model. So what were the drawbacks of the Rutherford atomic model? What did Rutherford say? First of all, you need to know that Rutherford actually said that electrons actually orbit around the nucleus, and how do the force required for that come? Due to the Coulomb's law, force of attraction. We know about that, right? Okay, so according to Rutherford, what happens is that if it is the nucleus, this is the positively charged heavy, right, mass concentrated center, then the electrons evolve around the nucleus according to Rutherford. Okay, so here the required centripetal force, right, to revolve, you need a centripetal force to not revolve, to move in a circular path, right? And where does that come from? That comes from Coulomb's, that comes from actually the Coulomb's law. Coulomb's law, okay. Okay, I hope that the spelling is correct. Coulomb's law, and I hope you all know about that law. That's an easy law. Actually, let me write it. The force that is equals to Q1 Q2 by 4 pi epsilon naught R squared. Q1 and Q2 are charges, R is the distance between the charges. This is actually the permittivity of air or vacuum, you can say. Okay, and this 4 pi is a constant, and this is a force. So if we take the charge of electron, if we check the charge of nucleus, we can find the force, right? And that's all about the Coulomb's law. Okay, so this is what that is told by a Rutherford atomic model. But here there is actually a complication. According to law of electrodynamics, okay, that's a law of electrodynamics, that is given by Maxwell. Okay, the law of electrodynamics by Maxwell. What does it say? That a charged accelerated particle, when you have a charged particle and when you have it accelerating, what happens is that it releases energy, right? It emits energy, and that is in the form of electromagnetic waves, and that's the origin of electromagnetic waves as that was proposed by Maxwell, and that was true. It was experimentally verified at that time. So here too, electron will be accelerating. It will not be changing its speed, but it will be changing the direction of speed, means it will be changing the direction of its velocity, we can say. So it's accelerating here, so it must emit energy in the form of electromagnetic waves. And when it emits energy, you know, it's we know that its velocity is proportional to energy, that is kinetic energy, right? So when it emits energy, its kinetic energy will also decrease, right? It is obvious. So when its energy will decrease, when its velocity will decrease, we know its radius is somehow related to its velocity here, right? So when its velocity will decrease, what will happen? When it loses energy, its velocity will decrease. The velocity will decrease, the radius will decrease. So when the radius will decrease, one day, it will not take that much time, but it will finally collapse into the nucleus. So it will finally collapse here, okay? And in this way, it will be losing its energy, and it will be collapsing here, to spirally collapse here, okay? So that is what law of electrodynamics tell us. Okay, so now let's also talk about another drawback that's not mentioned most of the books, okay, most of the places as well in YouTube. Okay, so and that is, okay, you know, when the electron, when it is given energy, right, yeah, it will be actually gone from its ground state, we call the state as ground state, and it will be actually energized. Okay, yeah, and we know its radius will increase, right? Yeah, and when it come back to the same radius, what happens, it releases that gained energy in the form of electromagnetic waves, right? And it cannot explain the line spectra of hydrogen. It explains it to be a continuous spectrum. What I just want to tell is, okay, according to Rutherford's atomic model, okay, an electron can be upgraded, it can be energized to any possible radius. So there are many electrons. If we take a sample of an element, there are many electrons, so they can return to any possible radius, and if they can return to any possible radius, they can release any possible electromagnetic wave of any possible wavelength, right? So the spectrum here must be continuous spectrum. There must not be gaps between the spectrum, right? But in hydrogen spectra we observe gaps, we observe line spectra. So it cannot explain how we got that line spectrum, right? So that's one of the disadvantages. Okay, I hope you have understood. You know, electrons, when they are energized, they move to a higher radius orbit, right? And they can return back to any possible radius. And there are number of electrons, and they move down to many different possible radii, and they release the electromagnetic wave of many possible wavelengths. So there must be continuous spectrum formed, right? But here it does not happen. That is one other disadvantage of the Rutherford's atomic model. And that's all for today. Okay, that's all. I hope you have understood the point of my video. Okay, so that's all. Thank you very much.